Hey, welcome. We're going to do a brief intro on transformers for my physics prep students for Lyons Township. And this is in conjunction with another video that's on YouTube that you're going to watch right after this one. So on this particular video, I'm just going to fill in a few small gaps that are in the other video. So first of all, a transformer is used to change voltage. So for instance, the power lines outside are at about 5,000 volts and the voltage in your house is at about 120. So we got to have a device to change that voltage and make it lower. And then when you're in your house, for instance, your cell phone charger, the household voltage is 120 volts and your cell phone operates on a couple of volts. And so again, we have to have a way to change voltage from one voltage to another. So the first thing I'll mention is transformers only work with changing current, with alternating current. So for us, we use voltage as a V. In some videos, you may see it called VAC. The AC stands for alternating current. It's got to change back and forth. The reason that occurs is because all a transformer is two solenoids. So let's say you got one solenoid. Here it is, okay? And it makes a magnetic field. So that magnetic field would point this way, okay? That's your magnetic field, and that was the previous unit. And what we want to do is we want that magnetic field to go into a second solenoid, okay? Now, if this magnetic field doesn't change, then nothing will happen in the second solenoid. If I change this magnetic field, then this solenoid will make its own magnetic field, and in order to do that, current will flow in the wires over there. So how do you do this? Well, if you constantly change this current, you're constantly changing this magnetic field, which means you're constantly changing the magnetic flux in this solenoid, which means you're getting a current, which is also constantly changing the flow in that solenoid. So when you watch the next video, you're going to notice they have two solenoids, and they're going to look a little different. They're going to look like, he's going to draw a sketch like this, okay, which would work. So this is a piece of metal, and he's going to wrap some wire around one side, and he's going to wrap some wire around the other. Notice there's different amounts of turns for each side. These two pictures are basically the same thing. You got two coils of wire. The magnetic field would follow along the metal and go from one solenoid to the other, okay? So again, these only work when the current is changing. And that's one of your questions on your worksheet, by the way. Therefore, it only works with AC power, not DC power, DC meaning direct current power. So like, for instance, in your labs you did with circuits, that wouldn't work. A transformer wouldn't work in those because that was DC current. It just went one way. It didn't change, okay? Something else that he'll mention and I want to emphasize, well, two more things I want to mention. Whenever you use a transformer, there's power, and the power in has to equal the power out. And that's at best. If the transformer is 100% efficient, the power out equals the power in. They're usually not 100% efficient. And if you'll remember, power equals current times voltage. So this power in this turn of wire has to equal the power in this turn of wire. Now, having said that, there's a consequence. So for instance, let's say you increase voltage. Well, if you increase voltage, and by the way, this coil of wire would have a higher voltage, because the power has to be the same in both sides, the current goes down, okay? And vice versa. If you make your voltage go down, then your current will go up. So down here I've got a picture. This is literally the transformer behind my house. And if you could tear this thing apart, what you'd see is two coils of wire, one having more turns than the other. You'll notice a couple things. So up here, now let me put my little pointer on here. So up here is the high voltage wire that runs around Lagrange. It's about 5,000 volts. You'll notice the wires are skinny that go into the transformer because the voltage is so high, you don't need much current. So the wires don't need to be thick. These thicker wires coming out, these are the ones that go to our houses. They're only at 120 volts, but they have to carry a lot more current. The V went down, but the I goes up. So that's why those wires are thicker. So it's kind of, it might be a little surprising that the high voltage line is skinny wire and the low voltage line is thick wire. But that's because the current does the opposite thing of voltage. So again, voltage goes down, that current goes up. Okay. The last thing I'll mention that won't be mentioned in the video, but that will be asked on your sheet, and that's something I would expect you to know and want you to know. For ComEd, they generate their electrical power at about 5,000 volts, and then it's stepped up in a transformer to several 100,000 volts across the state. Why do they do that? Well, if you make the voltage higher, you can have a lower current. And you don't want too much current flowing through your wires, because too much current flows through your wires, they get too hot, they melt, other things happen. So that's why ComEd steps that voltage up really high to several 100,000 volts. That power gets to LaGrange here, and there's actually a substation on Cossett Avenue by LaGrange Materials by the tracks. If you go east from the school, you would eventually hit that substation. At that substation, they knocked the voltage down from several 100,000 volts back down to 5,000 volts. Then that power goes through the whole neighborhood, and then one of these transformers every several poles knocks that 5,000 volts down to 120 to go into our houses. So this is it for this video. You're going to watch the one video that I found on YouTube that's really pretty good. The guy does a really good job. He did several examples for you, and then you hopefully will be able to complete the worksheet. There you go. I hope to hear from, or I hope to be back with you guys pretty soon.